All right, guys, so we are on to part 3. Hopefully you were able to do that construction just fine. We are on to part 3, which is where we deal with perpendicular lines and perpendicular bisectors of segments. So two lines, right, what you're going to write here is that two lines are perpendicular if and only if, when they intersect, they form a right angle. So you need to add this, when they intersect, okay? So two lines are perpendicular if and only if they form a right angle when they intersect. All right, so here's a diagram. We have line L, which intersects line M, and they intersect in such a way where there is a right angle created, a 90-degree angle. All right, and the way that we would indicate that is to say line, we would write line L, we would write an upside down T. That is the symbol. Again, symbols are important in geometry. That's the symbol for perpendicularity or perpendicular. Line L is perpendicular to line M. That's what this means here. It means that they intersect to form this right angle. Now here's the fun stuff. How do we construct the perpendicular bisector of a segment? All right, here we go. Gonna focus a little bit more down here so that you can see everything and all of the steps well enough. I'm gonna refocus my dot cam. And it says that given segment AB, and we are given segment AB, we are going to place the focus point, the sharp point, at A, okay? So I'm given this segment here, and from that segment, I am going to put, right, I'm going to put my focus point on point A. I'm actually going to use this one to demonstrate, and you're going to see how I eventually get that, and then this and this. Well, rather this, and that, okay? So I'm going to use just this segment as the demo, okay? So it says I need to place my focus point at A, and that's what I'm doing. And then it says to estimate a point that is a little further than the midpoint of the segment. Okay, so if I'm looking at it, I would guess that the midpoint would be right here. The midpoint would be right here. And so I am going to, I want my pencil point to be a little further from that point. Okay, so I'm going to put it, I know you can't see, I'm going to put it right about here. Not at the midpoint. You want it a little further down than the midpoint, okay? And then it says to put your pencil point there and then make an arc, which is what I'm going to do. So I'm going to make an arc. I make arcs my way. My arc is not as circular as that, but you might want to get it because we have to do something special with this arc. So I'm just going to make my arc, just kind of like theirs, okay? And so that's how we went from this just plain segment to what they have here, okay? That's step 1. Alrighty, so then for 3 it says without changing the distance, very important that you do not change the distance from the focus point to the pencil point. Okay, don't change the distance or the compass measure, that's what it's really called. Place your focus point at point B and create the same arc. So now I'm going to switch from having my focus point at A to now it being at B, not changing anything else, okay? And then I'm going to create another arc. So I'm going to create another arc, and the key here is to make sure that your arcs intersect each other. And that's what they're doing. They are going to intersect. Okay, so that's how they got this. So we started with this step, we are on to this step, and that's why this step and this step. That's why these two look similar. Okay, so the next thing we're doing, it says here, place your straight edge, remember don't change anything, place your straight edge on the paper so that it forms CD. So we are going to, and one step that we didn't do here, is to label those points C and D. Label the points of intersection. These are the points of intersection, C and D, okay? And then it says place your straight edge on the paper so that it forms CD. The intersection of CD and AB is the bisector of AB. So essentially what they're trying to say is take this and connect C to D. All right, and you can make it a line. All right. And so we have constructed a perpendicular bisector, okay? So again, it says the intersection of CD and AB, this point right here, bisects segment AB. So that means that these two, right, if we wanted to name this, we'll call it M for the midpoint. AM is congruent to MB. And it says to do that, label it M because it is the midpoint of AB. All right, and then we have AB, which is the same as the one here. Now, if you are still stuck on and confused about that, you need to rewatch the steps because you're going to be trying it yourself. But before you try it yourself, jot down the definition of a perpendicular bisector. So it says here a line is a perpendicular bisector if and only if it goes through the midpoint of a segment and forms a right angle, much like the one that we just constructed, okay? It went through the midpoint and it also is perpendicular to the line that it bisects, okay? So it has to go through the midpoint and it has to be perpendicular to the line it bisects. What you're going to do next, after you jot down that information, those notes, is you're going to try bisecting AB twice, okay? So you're going to do it once here, and then you're going to do it again here, following the steps that I gave you. Also, supplemental videos will be provided for constructing the perpendicular bisector as well as copying the segment. So watch those. They will be right in the description box. Please watch those supplemental videos, and you will have a practice packet, or rather just a practice worksheet after this, so you can practice these constructions. All right. The last thing that you're going to do is take down the definition of equidistant, okay? The word equi means equal, distant means the length, okay? So when one object is the same distance from two other objects, we say that it is equidistant from the other two. In this example, we have line CD, which is the perpendicular bisector. It goes through the midpoint, and it's also perpendicular to the line that it bisects. It can also be described as a set of all points equidistant from A and B. Any point on a perpendicular bisector is equidistant from the endpoints of the segment it bisects. So therefore, we can say that C or D, or any point on CD, is equidistant or the same distance from A and B. Therefore, CA, the length of CA, is the same as the length of CB. Go ahead and watch those supplemental videos and practice your constructions. Please see me if you have any questions.